Welcome, fellow engineers, to a deep dive into Site Reliability Engineering, or SRE. Today, we're not just learning definitions, we're uncovering the why behind building systems that don't just work, but thrive under pressure. Back in 2013, when Google services briefly faltered, it wasn't just a technical glitch, it sent ripples across the global economy. That incident, among others, really cemented the idea that operations, when approached as a software problem, can revolutionize how we build and maintain systems. SRE isn't about traditional ops, it's a fundamental shift towards optimizing for the right amount of reliability, balancing it with rapid feature delivery. By the end of this lesson, you'll be equipped with practical insights to build more robust and efficient systems. Let's explore the core principles that enable this reliability revolution. Let's kick things off with a game changer: error budgets. This concept tackles the age-old tension between making systems absolutely perfect and rapidly shipping new features. Think of it this way: if your service level objective, or SLO, promises 99.9% uptime, you're implicitly agreeing to a 0.1% error budget. That's roughly 43 minutes of acceptable downtime or degraded service per month. But here's the non-obvious insight. Error budgets aren't just about total outages. They encompass slow responses, partial failures, and any degraded user experience. A page load that takes 5 seconds might actually consume more of your budget than a brief 1-minute outage because of its broader impact. Google's approach is brilliant. When the budget is healthy, teams push features aggressively, but when it's exhausted, deployments freeze until reliability improves. This creates a natural, healthy tension that optimizes both reliability and velocity. Netflix even intentionally burns error budget through chaos engineering, learning from controlled failures rather than being surprised in production. It's about making reliability a measurable product feature, not an afterthought. Next up, let's talk about service level indicators, or SLIs, and service level objectives, or SLOs. These are your contracts for reliability. SLIs are the raw metrics that measure user perceived quality, things like request latency or error rates. SLOs are the specific measurable targets you set for those SLIs. The real mastery here isn't just about tracking availability. Modern SLOs go much deeper. For instance, we look at latency percentiles, like ensuring 99% of responses are under 200 milliseconds. We consider correctness. Is 99.99% of the data returned actually accurate? And coverage. Do 99.9% of features work for 99.9% of users? Stripe, for example, focuses on money movement SLOs, tracking the success rate of payments, not just if their API is up. A fast API response that fails to process a payment is far worse than a slightly slower one that succeeds. This shift ensures you're measuring what truly impacts your users and your business. Now, let's connect how we watch our systems with how we make our work more efficient. Traditional monitoring often alerts on symptoms, like high CPU usage. SRE monitoring, however, focuses on user impact, like a slow checkout process. This is where the golden signals framework comes in. Latency, how long requests take; traffic, how much demand hits your system; errors, the rate of failed requests; and saturation, how full your system is. Uber's philosophy is key here. Page only when user experience is degraded and immediate action is required. This dramatically reduced alert fatigue. This leads us to toil, that manual, repetitive work that scales linearly with service size. SRE teams aim to keep toil under 50% of their work, dedicating the rest to engineering that scales sublinearly. The automation hierarchy ranges from no automation to fully self-healing systems. Google's insight: if an on-call engineer handles the same issue twice, it becomes an automation target. It's about building systems to be inherently more reliable, reducing the need for human intervention. Finally, let's touch on some advanced SRE patterns and bring it all together. Smart teams integrate canary deployments with error budget health. When your error budget is healthy, you can roll out new features faster. If it's depleted, you extend those canary phases or even pause deployments. This allows for safer, data-driven releases. Another critical practice is blameless postmortems. The goal isn't to find who caused an issue, but to understand how the system allowed it to occur. We focus on process failures, not human error, to prevent recurrence. And then there's capacity planning with lead time. SRE teams model capacity based on growth and feature impact, understanding that procurement and setup times require significant lead time, often more than organizations realize. This proactive approach prevents future outages. So, we've covered how SRE treats operations as a software problem, how error budgets balance reliability and velocity, how SLIs and SLOs measure what truly matters, and the power of automation and blameless incident response. The SRE mindset is about making reliability a measurable product feature, not an afterthought. Now, consider this. How would you design an error budget policy for a new microservice in your own environment?